Cool. So welcome everyone on this month episode, removing complexity from integration tests using test containers. And who we are and what is CJUG. We are a community around the Java ecosystem, and we are trying to learn and contribute to JVM technologies. We are also trying to help in mentorship or finding career opportunities. So if you are hiring, please reach out to us. If you are seeking for a job, please see our jobs mailing list that is available on cjug.org. And we also want to have some fun and build things in the meantime. If this is your first time, please share the love and invite someone for our next event. And if you're interested in doing something for the Java community, please consider volunteering and or speaking at CJUG. And you can reach out to us on Meetup, Twitter, email, like you choose. We have a very brief code of conduct. Please be nice to each other. That's basically all. And we have over 2,200 members, but we know that there are way more Java developers in the area. So if you know them, please let them know about us. We have an upcoming event for next month. I believe we might have a talk about JReusable. And also it seems that we might have a in-person DevNexus in April. So take a look at their schedule. It looks pretty cool. Logistics, this is a very old slide. Hopefully you all know the Wi-Fi password and the location of your kitchen and bathroom. And also we are supported by JFrog. They help us keep running. For example, they are providing the Zoom license for us. So thank you for them. And our speaker today, Oleg Shalayev from Estonia, and he's a developer advocate at Atomic Jar, and he works on test containers and makes integration tests easier for us. And Oleg, I believe with that the stage is yours.
Thank you very much, Jonathan. Hello, everyone. I'm very happy to see all of you here. And we're going to talk about test containers today. Right. Jonathan mentioned DevNexus. I'm pretty sure there's at least one excellent session about test containers there by yours truly. So do check it out. If you manage to get there in person, I have my hopes up as well to be there in person and we can meet in real life. But all those lyrics, if we move them out of the way, let's talk about integration tests. Let's talk about test containers. Let's talk about how you can write better and more maintainable and simpler integration tests. I don't see the chat currently, so if there are any questions, please just use voice, right? This is simplest, or ping somebody in chat if you don't want to use the voice yourself. Right, so my name is Oleg. I work as was mentioned, as a developer advocate, the developer relations team at the company called Atomic Jar. Atomic Jar is a small startup. It's there are like 10 of us, and this is the company that was established by the maintainers of the project called Testcontainers. So we do like to believe that we as a community, as the ecosystem, as developers, we can write better integration tests. And we think that better integration tests allow us to create better, more robust, more reliable software, which no one can argue against. So this is a very good point, right? You can find me online if you want to ask any questions and you don't feel like taking time here, or we just run out of time because we talk too much about other cool stuff. You can find me online. This is very easy to do. Right, so with all the introductions out of the way, let's talk about the integration tests. when we talk about testing, one thing that we normally talk about are the types of tests. And for a number of years, people represented their testing efforts, especially their automated testing efforts, with the pyramid, with a triangle, where the base would be the largest and the middle part will be, well, smaller than the base, and the top would be even smaller. And they would say that those are the unit tests at the base. There are the most of them, and the largest chunks of your test suite, and then integration tests in the middle, and then end-to-end tests at the very top. And somewhere a few years ago, and well, it was a few years ago before COVID, and it is still a few years ago in the current time as well, because, well, not much has changed. Still, very many of us live in 2020. People started to challenging that notion with their experiences, and especially coming from the teams who deploy and develop microservices. This notion that tests, there should be, the most of tests should be unit tests, that check implementation details, was not the most helpful. When we develop microservices, we normally glue together, well, services that do small, relatively simple things. They might not be simple in the inside, right? It could be a very complex recommendation service using machine learning and artificial intelligence. It could be a just-in-time compiler as a service that would take your Java bytecode and then return the machine code that you need to install somewhere. But the contract, how we use and consume those applications, is a little bit simpler, right? So Spotify came out with a blog post how they do testing of their microservices with the honeycomb structure. So there are unit tests, they test implementation details, but they're smaller in number and size. They do a lot of integration tests, which check how different components work together, but they do that in isolation. And then end-to-end tests are considered not the best practice either, because it's very, very hard to maintain the whole environments of well, the fleets of microservices that they use. There was recently a very interesting article by Lyft, which is sort of the ride-hailing service, how they do testing and how they initially did just recreate the whole production environment on very beefy VMs for developers to test. Then you can sort of raising up the whole fleet of microservices. But then it became very, very much impractical. So integration tests are the largest chunk of our test suite. And in this talk, we're going to concentrate on talking about them, integration tests, which could cover the most of your use cases, the largest chunk of your use cases, and which could cover and take the most time of your test suite, and which also could provide you with the most reliability and confidence in the fact that when you release your software, it actually works with the outside world the way you expect, right? Not talking about the particular implementation of individual methods, but rather integration between different components, right? And integration tests, just as a recap, refers to the tests where we go through functionality of multiple modules at the same time. So they could be different microservices, or they could be different components of a single system. For example, a single microservice and its database or its cache or proxies or whatever other components are in the system, but they're inherently adjacent to your service. And we don't spin up the whole system of microservices because it will be impractical, but we only test one project, one subcomponent with the doubles. We test it in the ephemeral environment which doesn't require us going further than one step away, like one dependency away from this microservice or like service or a component, right? And then ideally, if we talk about the API, we would use something called contract tests to ensure that the double that we test against is actually true to the behavior of the actual system. If that dependency is not an API, especially not an API that we control ourselves, then we don't need to ensure the faithfulness of the double because we just rely on the technology provided. For example, if our service dependency is a database, then we assume that whatever version of the database we're using is the same as the production database we're using, right? So we would like to test our component with all the service dependencies that are one step away from it, but not more. Because if we start going deeper, we need to raise and deploy the whole system, which is impractical, slow, expensive, and very often infeasible. And if we don't do tests with the actual components, then we are not catching enough errors, because that would be the unit tests, right? How do you usually do and how we isolate the dependencies and services in the current age and time? We run them, well, either in the cloud, but when we talk about development and CI environments, we run all services within the boundaries of a Docker isolation. And the boundaries there, it's not the maybe isolation is not even the most precise word that we want to talk about, but this is a unit of deployment. We can put a database in a Docker, we can put a service in a Docker, we can deploy our application in Docker if we will, and we can manage its lifecycle and we can access it through Docker, which is very, very good. But Docker is a little bit awkward to use by itself. The most teams who use Docker directly for integration tests use Docker Compose. They dabble in creating large YAML configurations and then maintaining those, and stumbling in a number of challenges with how Docker works and how Docker Compose configuration is flexible or more often inflexible. We think that there could be a bit better solution. And that solution is, of course, Testcontainers. Testcontainers currently is one of the most popular libraries for integration tests of services with services, that rely on Docker. Testcontainers is not a new project, actually. How many of you know Testcontainers? Can you do the little quick count of? I want to see like the chat of participants. How many of you know Testcontainers? Do we emoji or a chat message? Natalie says, haven't used it before. This is very well, very good. This is excellent. You are in the right place. Right. FU, aware but not used. Excellent, in the right place as well. Okay, that was just a very quick test. Let's do this. Testcontainers. Testcontainers was started by Richard, who is currently the CTO of Atomic Jar company, and who is the original author and maintainer and the visionary behind the Testcontainers project. It is a library. It sits on GitHub. It's an open source library. What it does in a nutshell, it wraps the Docker Java library. It provides you with a Java API for controlling Docker environments, Docker containers and images through code. And then it has integrations with the test libraries and everything. So you can nicely connect your code and your tests with this capability of managing Docker containers and images. It does the Docker discovery for you. It does run tests and tries to simplify the user experience for the new users. And it does, very, very importantly, it does containers cleanup. It cleans up all the things that usually are left on the JVM shutdown, right? So the premise is that you can integrate your test code with a Java library, and it will spin up Docker containers for you as necessary. And after your tests are done, there is nothing to clean up or anything, which is essential for the tests, because tests need to be repeatable. Tests need to be sort of disposable and not leave a lot of garbage around, because otherwise you will be fighting the CI issues way more than you're actually writing tests. And when I talk and when I say Java or whatever I'm going to show you there, it's not just Java. Testcontainers is a very big community project, and there are implementations of Testcontainers functionality in all necessary modern languages. There is Testcontainers Go, there is Testcontainers Node, which you can use with JavaScript or TypeScript applications. There is Testcontainers Python, there is Testcontainers Rust. There might be something else. So the technology there is not Java specific, and which is very, very good, because it can, if you think this approach to do testing is interesting, right, you can very easily convince the whole company or a large chunk of developers to at least look at it, which is very, very good. Right. So Testcontainers is a library that supports unit tests, provides lightweight, throwaway instances of databases, browsers, anything else that runs in a Docker container. And we're going to look at this. I want to run you through a practical example of different ways how you can use Testcontainers Java on your normal small example microservice. And we're going to run a few tests now, and we're going to see how it works. And I'm going to try to answer any questions that you have in the sort of ongoing fashion. So here we're going to go into the Intellij Idea, and I have here my Spring application. It's a very, very simple Spring application. How many of you actually do web applications? Or if you do not web applications, what do you do? Libraries. It's Spring, right? Everyone is using Spring. How many of you are not using Spring? Not using Spring, but familiar. There, Spring and Vertex. Excellent. Using Vertex. Oh, Vertex is very popular in this group. Nice. Nice. Vertex is interesting. Spring is probably currently still a de facto standard for frameworks for microservices and applications written in Java. So we're going to go with that for the example. Here's my project. You can find it if you want to experiment with it. It's a very simple application. It literally, it is the demo application, and it deals with ratings for the conference talks. There is a talk ID and the value of a rating, and this is our whole model, right? This application, since we're going to talk about the test, this application just needs to provide us with a canvas for doing the tests, right? So it's very, very, very simple. And then there we have a single controller that will be able to talk to Kafka, and then it will be able to pull data from two repositories. And just so you know, one is a database connecting, the repository connecting to the database, right? So through JDBC template, and one is a repository that connects to Redis. So we have plenty. This is a sample application that is a microservice that can serve HTTP queries back to you. And it also talks to 3 different pieces of service dependencies: database, Redis, and Kafka. We would like to test this application and do a couple of tests and explore the Testcontainers library. I have some test infrastructure here ready for me. I prepared it in advance because I just don't feel that like typing all this code here. I'm gonna run you through this hopefully very quickly, right? So we have an abstract class. It should be abstract class abstract integration test. And it will control and define how we do tests. And we're going to run it with Spring Runner. And we're going to say that if we run our Spring application, please run it on a random port. It seems like a small detail, but it's very, very important. You never want to use a fixed ports in your tests, because if you spin up services, your application or any dependencies on random ports, and then configure your application to use those, then you can run multiple instances of the test suite in parallel. It might be not the biggest challenge on your local machine as a developer, because, well, how many test suites do you run at the same time on your local machine? But in something like CI, this could very, very easily be a problem, because if some ports become unavailable, then, well, you cannot bind anything there. So this is one of the problem with more rigid test environments and setups, where, for example, you use Docker Compose for spinning up your database, Redis, and Kafka, because they only could be one instance of those, right? So we would try to do this the right way. We're going to randomize all the ports. So our abstract class, and one thing that it also defines here is the request specification. And request specification comes from the Rest Assured library, which is a very nice, fluent API library that allows you to talk to, allows you to define HTTP queries in a very nice programmatic way. So here we just built the basic specification for the request, which means that in our tests, we'll have an easier time of using them. And we have a very simple test, which is the demo application test. It extends our abstract integration test, and there is the default context loads test. Here, I'm going to run it. And I assume that it should pass. I think it should pass. I hope it passes. Right? So you might think that this test is sort of a little bit boring because it's empty, it doesn't do anything, and it's sort of unnecessary. But yeah, it works. So it actually tests a very few things, which are very important. First of all, it tests that our application compiles nicely, then the project runs. And the second thing is that our environment here, our Spring application, wires together nicely, right? So all the beans are found, all the beans are used in the proper way. We see the banner, we see Zoom controls go away. We see that Spring starts, it's all good. We run it, build successful tasks, everything is very, very good. So now let's try to explore this application and let's write a more reasonable test. To have a more reasonable test, we need to add a little bit of data to our database. We do this using a schema SQL file under our resources. So in the test resources schema SQL, we can say we would like to have some data. So into our table talks, which we'll create if it doesn't exist, we're going to add the welcome to JUnit 5 and flight of the flux. Right? We just saved it. Let me rerun this. And now I would expect this test to fail. How many of you think they know why this will fail? Or why at least I think it will fail? It fails. It fails. If you don't know why it failed, this is very good, because normally I would not expect developers to know this, but our application here is set up in the normal way you get a Spring project out of the Spring initializer, right? That means that here, when we see that, we have the H2 as a dependency. And we use H2 as a database. And if there is no database configuration, if there is no nothing, then Spring will instantiate the H2 as an in-memory database and use it for the database purposes. Now, our SQL here uses the Postgres syntax, which the error in the SQL statement inserted into signifies. This is H2 doesn't know how to handle this, right? So what we're gonna do? We need to remove H2, and we need to run our tests against the actual Postgres. This is a Postgres syntax, so against the actual instance of the Postgres database. We do this very simple. We added the dependencies on test containers, which we have here. I thought I needed to add them, but they're already in my sample project. We added dependencies on the Postgres module. We added dependencies in JUnit Jupyter, and where the core test containers is being pulled automatically as well. They are all seeing here, you have a dependency bomb. So all the modules work together very nicely. You import that. Now we have test containers as a library available to us in the project. Let me just double check that. Right, somewhere here should be work test containers anytime now. Yeah, so we have the test containers, everything there. JDBC, JUnit Jupyter, Kafka, test containers, core. Very good. So our project is now ready to go. How do we enable test containers and test container support in our Spring application? There are different ways, and the simplest way is to use a JDBC support in test containers, which is configured using a property. So if we look at this test here, and if we configure a special property for our application here, we can make sure that this test runs and integrates with test containers. The property here that we need to add is the JDBC URL. So if we add Spring data source URL, which is the property that configures the where our database is located, and we just do, normally you do JDBC, and then what's the link? Normally you can put a JDBC URL here. We're gonna do a different thing. We're gonna say that we want to use the test containers magic with our JDBC URL, and we're gonna say which Docker image we want to use. We want to use the PostgreSQL, and the tag will be 14 Alpine, right? That's a small image that you can use. Our database will be test containers workshop. Right. We added one single property. We didn't change anything in our test suite. Obviously, those properties are on the abstract class. So when we run our demo class here, it should supposed to work. And we run the test again. Let's see what happens. Because this is very, very interesting. Now our test is run. When the test is run and the property is being injected and used, the JDBC URL is being examined. Now, it sees there that the JDBC URL has the test containers TC shorthand in there, in our property here. And the integration with test containers JDBC, what it does, it creates a Docker container. It discovers a Docker environment that we are using currently. So it connects to Docker. It connects to Docker that I have available, right? And then it downloads the image that we're requiring, which is the Postgres 14 on Alpine. And then it runs that image, and then it injects the configuration for using the database inside the Docker image back into our tests. This is the simplest way to use test containers with your Spring application. is just by using the magical JDBC URL. I think a similar support is for reactive JDBC, right? So, but you might need to follow the instructions for the reactive. Right, this is it. We wrote the test. This is our test. We didn't even write it itself ourselves yet, but we created a test that actually runs our Spring application and also runs the service dependency that it depends on, which is the Postgres database. And now our application runs. And if, for example, here we do just for, if we do autoward, and we do, what was the ratings repository? No, was this one the JDBC? No, this was Redis. What was the other one? Tox repository. Tox repository. Right, and then if we do repository, what can it do? Exist talk ID. Right, this is very interesting. Exists talk ID. What was our sample data? Right, one. We'll try one. Right, this is assert that. We'll import from the, where's the search for J here, right? Assert that exists is true. Wait, what? String. Right, let's try this again. We could rename the test, but we're gonna try and fetch data from the database right here, right now. Ooh, this is exciting. I didn't plan to do this. So now it might fail, but it shouldn't. I think it shouldn't. Unless the ID there is not one, which it might well be not one. Yes, it fails. Why is that?
Check the schema SQL.
Schema SQL, wait. Oh yeah, welcome to JUnit 5. Oh my God, this is the ID, right? Oh, so good. Thank you so much. Yes, see, that's what happens when you do things that you haven't tried just before. Right. Our test is gonna run. This is very simple. Well, it's gonna pass, of course. It should pass. Now with the correct data, the schema is being loaded into the database. Our test is green. We are very happy. This, of course, doesn't use the REST API of our application, but this does verifies that the context loads, the database starts, database is populated with our data, and everything is peachy. Now it's very easy to create more tests that will actually use the actual logic of our application without any mocks, without any additional complexity that we need to create ourselves, right? It just uses the real database. How can I be sure that this is a real database? Because this is the same Postgres image that you would use in production, right? If you use a different version of Postgres, well, you can just very easily change the thing, right? So if we want to try on a different Postgres, well, that's it. Very simple, super simple. This way you can run your tests, and the test will run if you run Maven test or something, or Gradle check, right? And that means that every developer will run the integration tests. That means that your CI will always run the integration tests. And that means that those tests will catch many more errors or types of errors that you ever would be able to do with unit tests or tests with mocks or anything like that, right? With absolutely no effort whatsoever. Let's do more. Let's do more. In the same test here, what we can do is we can also try and build some tests which are using rest assured. The correct way of doing integration tests probably. So we're going to do another test, and we're going to do again a void, and we're going to check an endpoint which exists in every application, right? In Spring application, the actuator, the healthy endpoint, right? So we already have the specification from the abstract integration test. So our test could be very, very simple. If we given, and then this request specification that we have, we do when we try, wait, let's do this. When we get healthy, what was the correct actuator healthy? Actuator healthy. Then we
I guess it's just health.
What?
The endpoint. I guess it is just health, like the built-in, like /actuator/health, not healthy.
Yes, maybe health. Yes, of course. And then what we get to 200, right? Status code 200, and then we can log something, right? We don't need to log. Well, let's log. We do need to log. What? Log if validation fails. Log detail. All. Right. A very simple test with rest assured. What did we do? We say when we're going to request the endpoint, please tell us if it's 200 or not. And then if anything fails, drop everything and log everything that you got. And this test will now fail. And it will fail with a very interesting exception there. It will take us a moment to instantiate this. You can also see that this test also extends our abstract integration test class there. So it gets the instance of Postgres for itself, but it doesn't get Redis. And the health endpoint there wants to check that Redis is up and running as well. So now we need Redis to make sure that our health endpoint works, and it would be very easy to integrate this. How do we integrate Redis? Who knows how do we integrate in Redis? We go into the probably somewhere here, and we say we want Redis. We want Redis. There is generic container. There is an API in Testcontainers called generic container. There is an API called generic container. Generic container is an abstraction that you can use that knows how to, well, it stands for any container that you want, right? So we're going to do new generic container, and we're going to say we want Redis. And I know that Redis will be something like Redis 6 Alpine. This is the Docker image name that you can specify there. And then what we need to do, we don't need to depend on anything, but what we need to do is with exposed ports. Since this is Redis, this is the service that we need to access through HTTP. We say, please get us the port 6379, right? So now our Redis is here, and we can do what we can do. We can do a static field, right? Final field. This is our Redis. Now it's not started. It's not started yet. It's not started yet. We need to start it, right? We need two things now with this. We need to start it, and we also need to provide configuration to our application where the Redis is located. The beauty of this with exposed ports is that this port is in the container. So Redis will bind to 6379 within the Docker container that it runs, And now that port needs to be published to our host. So normally when you do Docker run, right, you do -p and then you do port and port, right, like this. Well, the beauty here is Testcontainers manage that for you. So it binds and publishes this, exposes these ports on a random localhost port that you have. And then Redis. Wait. So let's create a method. Let's create a method which public. We'll need this method to start anyhow, right? Public static void configure, right? And we do Redis, and then, for example, we can do get host, right? Or we can do get mapped ports and the 6379. And Testcontainers will give us the value to which this port has been mapped. So we need just to start and configure our application here. What we do that with the dynamic property source, which is a very, very interesting annotation that is available in the test class pass with your Spring applications. We do dynamic property registry, and we're going to use this registry to register the configuration for our Redis. So we do Redis start. We just want to start it. Start. Stop it. And then we do registry at, and then we just do the configuration for our service that we have, which is the Spring Redis host. Right, and this would be Redis. This needs a, it takes a lambda, so we do get host, right? And then we do the same thing for port. And then we do first mapped port because we exposed only one, right? So this is our integration between our newly found Redis instance running in the Docker container from this image. And this is how you glue it together with your Spring application. This means when we're gonna run this test, it will find that there is a configuration necessary with the dynamic property source, and it will call this method. It will start Redis, and then when Redis is started, it will obtain the address where this Redis is running, and it will add to the dynamic property registry. And then when configuring the application, this registry will be used, those properties will be used, and our application will find Redis in no time. So now our test will run, and it will have Redis and Postgres running in the database, in Docker containers. And the beauty of this approach, there are different approaches how you can integrate your tests and Testcontainers library. You can do it with the predefined modules. You can do it with Magic JDBC support. You can do it with manual lifecycle management. And this could be any generic, any container, anything you can run in Docker, you can run in generic container this way. Anything that you run in Docker Compose, there is a Docker Compose module that you can use to migrate off Docker Compose to generic container. The API there is very extensive. So for example, you can create network and you can connect different services running in Docker containers with the same network. You can expose host laptop host machine ports to Docker containers if they need to connect the other way around. You can do various things there. The API there, you can do with commands if you want to specify different commands. You can copy files back and from containers. You can also consume the logs from the containers. So the whole range of API for you is available. Anything basically what you can do with the command line, even more what you can do with the Docker Java library. Everything that is available to you with a very simple Fluent DSL that you can expose, explore, and use from your ID. This is one, like, so, and this is the lyrical, like, off topic. This is what one of the favorite features here that I have is that You can take, if you have the generic container only, you can see what Docker can do with it. But if you have special modules for particular technologies, for example, for Kafka, then you can expose and see what's there. Let's add Kafka. Let's add Kafka. Actually, we have a few minutes left, so I'm going to speed this up. Well, not speed this up. I didn't ever want to actually write this test. This is another test that will use actually a controller test, right? And it's already pre-written for me because it requires a few interactions with our application. So there is a test method. It extends the abstract integration test. And what it does is it takes the welcome to JUnit test, and again, it submits ratings for the talk using the post on the same request specification that we had, right? And then it awaits the ratings, and then in the loop, it submits more ratings, and it awaits the ratings back. So this is the fully functional test that we can run that will exercise our application. And this, of course, will fail. Not because it's a, wait, what? Right, I'm an idiot. We're gonna import the JUnit 5 test. We're gonna run the JUnit 5 test. Yes, this is very, very, very simple, right? Right, this will fail, of course, because this test now, the application to fulfill the functionality that we're asking of it requires Kafka, because it sends rating to Kafka and then it pushes through. It's just how application is. It's not the fault of the application. I wrote it this way, but it is what it is. So now we need, besides having Redis and besides having that thing, we also need Kafka. How do we do this? Who knows how they do this? It's very simple. It's very simple. We do Kafka container. Kafka container. Wait, what? Default image name. Right, let's do this. Wait, what? Yeah, it needs Docker image name. I think we need the tag as well, right? Default tag. I think so. Right. Some modules are exposing API. Using the predefined tag is better. Always better, right? So now we're gonna expose Kafka. So this test, of course, failed as we expected it to fail because there is no Kafka. It was 500 because there was no Kafka. Right, let's not look at the log there. Right, we start Kafka. We need to start Kafka with the startables. Deep start, and then we just do Redis and Kafka. Oh, we can do that in parallel. So we're going to start both containers, and then we need to add the Kafka configuration registry at what was the parameter? Spring Kafka bootstrap servers, right? And it is, of course, Kafka. What's the get bootstrap servers? So Kafka here, wait. Right. It accepts a lambda. Right. So here's the, I'm going to rerun the test in the name of saving time. Wait. What is this? Right. Just to save time, I'm going to run and talk in parallel. This test will pass because, of course, now we created Kafka. And this is very, very interesting. So Kafka is provided by this special Testcontainers library module, right? This is this module that does Kafka. You just enable it and import that explicitly. But what is interesting is that now, instead of using a generic container, we can use a service-specific container there, which is now Kafka, which is very, very good because you might not know what configuration options are available for technology of your choice, right? So for Kafka, you need the bootstrap servers to connect, right? And whoever manages and maintains the module for you, this Kafka module, Kafka container, knows probably more about Kafka than just a normal average application developer user that just need to depend on Kafka. So now our test, look how quickly our test run. Our test run in 8 seconds. This test creates a Kafka container, Redis container, Postgres container, runs all that, runs our tests, and just exercise our application, which is, I think, very, very simple. So there are 2 libraries essentially that I use there. One is Rest Assured to ensure that we ping our application correctly with Fluent API, and Testcontainers Java, which just ensures that our service dependencies are there when we need them. Now, there is also integration with JUnit 5. If we have a test like this, we can do test containers on it, and then it will do, well, you can use even more ways to manage the life cycle of your service dependencies there. But normally, either you can also do Postgres, like you can do, I think, PostgreSQL container, Postgres container, right? So normally you either use the modules that are predefined for you for the technologies, and Testcontainers has a ton of them. So if you look at them, there are almost all the databases that you ever wish to have: Mongo, MySQL, Neo4j, Oracle, Postgres, Couchbase, CockroachDB, Cassandra, the Magic support for JDBC, or reactive things, and then other modules like Kafka, local stack if you use AWS, mock server if you want to use the mock third-party API dependencies, RabbitMQ, and so on. Toxic proxy if you want to figure out what happens when network is not up to your expectations, and so on. So a ton of modules that are provided for you. And if they're not provided, it's very, very easy to make use of the generic container. Now, there are also even better things. So you can manage lifecycle yourself. There are also something called reusable containers, which is where you can, it's an experimental API, but it's very, very cool. You can keep the Docker container running after the JVM application exits. So you can reuse the same instance of the container for multiple runs of the tests. Sometimes you want it, sometimes you don't want it. So you need to enable it manually, both in the environment and on the API. But this is something that you can use. For example, if you want to, I don't know, something like spin up a Mongo container or spin up a Kafka and then use it in local development and keep it running even with, like, while you restart your application, you can do that totally. It's a lot of fun. And now, after all this said and done, very often people say, oh, like we don't want or can't have Docker, and what to do, how dependent on Docker Testcontainers are. And the answer is Testcontainers uses the Docker as a runtime to run your service dependencies. It's a really, really good runtime. It offers you very good choice of API for managing your applications, specifically for tests, copying things back and forth, the lifecycle and so on, everything, networks, connecting things together, executing commands, and so on. And if you don't have the Docker on your local machine or in your CI, there are a number of options, or don't want to have the Docker, right? The Docker client application, for example. There are a number of options. Atomic Jar is working on something called Testcontainers Cloud, which is currently in private beta, but which can decouple your Docker runtime environment from your application tests. So you can use the service. It's a software as a service thing, like it was a sort of a serverless version of the backend for your Testcontainers tests. And you can use that. You can run your test. Your database will be spin up in the cloud environment, and then your tests are done, and the database is discarded, sort of ephemeral dependencies as a service. If you're interested in that, I would be happy to talk about this. This is a very exciting project. And also, if you just want to run your things locally without any cloud offerings, we did a comparison of being able to run Testcontainers Java test suite itself, right? So we used our test to run with different ways of running Docker locally. And Docker, the scope is, of course, is compatible. It's a reference solution for that with a very little effort. But also an interesting thing could be running Minikube, which exposes Docker. There is a little bit more effort. You need to know what you're doing, but it is doable, and you can run the tests for Testcontainers Java itself. So you can run your integration tests with that. Whether this is something you want to do or not depends on the particular circumstances, of course, right? And we can run the whole test suite with Podman, and we talked with the team, and we're talking to the team to figure out what is happening there. So all in all, that, and just the final thing, you're the first one to know because I didn't publish it yet. Next, if you're interested in Spring specifically, next week on Tuesday, we're gonna have a live stream with Josh, which I feel is very exciting. So if you are into talking about Spring, you can maybe check this out. It's just next week, so that is all fine. Right, this is all in all everything that I wanted to do and show. If you have any questions, I'd be happy to answer them. If you have to run off lunch to do something else, I would understand as well. And then we'll see each other online. Oh, if you're interested, I completely forgot. Right? Yeah, if you're interested, right? I'm on M1 Mac, so some Docker images don't work here normally. So all the tests that I used were using the Testcontainers Cloud, right? So all those Docker things that were run there were run in the cloud, right? So the Testcontainers determined that I want to run in Testcontainers Cloud, that my application there is running, and connected to that. And I forgot about that, to be honest. And you didn't know anything, and you didn't know any better just watching that as well, because there is no visible difference. Right. So that is that. I hope this was interesting. Do we have any questions?
Could you post the link for you and the Josh Long talk?
Yes, I can. It's currently unlisted, so please don't spoil it yet, right? I'm gonna you can share it internally, right? Just don't take it on Twitter yet, please, right? I want to be the first one to post about it, right?
You can also share it in the meetup event, like in the comments, and I believe people will get notification about that.
Yes. Oh, absolutely. That'd be cool. I'll publish it eventually. It's ready. I just didn't get to announcing it, but yeah, it's happening on Tuesday. we're gonna talk about Spring and hopefully test containers. We'll definitely talk about Spring because Josh is the guest, but hopefully we'll talk about test containers a little bit as well.
I'll just add that I've used Docker containers to do integration tests, and I highly discouraged them because it was too much work to set up. This looks really wonderful. Programmatic setup looks delightful. Thank you.
Oh, thank you. Yes, and this is a very common sentiment, right? Because manually managing Docker containers, you either need the whole life cycle and it's separate from your application, and it will break, and then you will have to figure out why it broke. So here, what we have a very nice integration with the IDE, which is very, very interesting. Where's my IDE here, right? So my tests are in IDE. My configuration for the application is in IDE. I don't need to write any like application properties files, right? All with the API. Yeah, it's a delight to use. I know that some people have told me, you know what, that they started using sort of test-driven development because of how easy it is to set up with test containers. So because tests like this, test-driven development in Java is a little bit awkward to use sometimes, right? Because if you want to write tests before you actually have the functionality, then the classes are missing, and then the IDE kind of fights against you instead of helping you. But like writing API level tests like this, simple, right? And then when you have the environment to support this, it's all just a bliss. So yeah, I appreciate the good feedback.
Next question. Have you worked with any companies that had other teams, companies that have multiple teams, where the other team was responsible for writing the mock server container?
No.
For their application.
Yes.
So
yeah, I understand the question, right? So just correct me if I understand it wrong. You have multiple services developed by the same company, internal services, and some of them depend on the other services, right? So you need to mock them to provide this one step away from your container, from your service, right? Because you don't want to spin up everything. And for that, you need the mock service. And you're asking whether I have experience, or maybe better question is, what is considered a good solution for who needs to maintain those mocks, and how to organize communication about when you want the teams that provide services write the mocks for them. Is that correct?
Yes.
Yes, unfortunately, personally, I didn't work in any setups like this. My experience is from a little bit different field. But as far as I understand, as far as I heard from the community, is that it is simpler to, it is ideal if the people who maintain the service provide mocks for that, right? But it is challenging on the communication, level, right? So it is simpler to start with maintaining the mocks yourself, though I would highly encourage you to try to talk to those teams, right? Because that is better. And then, but if you use the mocks, you need to, if you write the mocks yourself, you need to ensure with the contract tests that the mocks are actually doing something more or less reasonable things. You can do that, but it's a little bit unorthodox. I know that for some modules, specifically for cloud technologies, right? It's a different setup because there is no internal teams, right? But for the cloud modules, the teams who provide technologies also very often contribute and maintain the test containers module for that, right? So for example, there is a G-Cloud module in test containers for the Google Cloud Platform, and they run it and they use the emulators that they obviously themselves maintain, the emulators, right? So to be like, I don't have a good answer to you, but I'm sure that this setup is doable. And I would ask you, actually, if you mind, maybe you can join the Testcontainers Slack workspace to ask a little bit more questions about that. I think that would be a very, very useful point of reference for anyone. And that's the easiest way to connect with the community who are using Testcontainers. Right? It should be available somewhere on Testcontainers website if you're getting help, right? So it's, the link is, wait.
I found it.
Yeah, it's there. Somebody,
also, just go ahead.
Yeah, somebody there should be able to respond meaningfully, I think.
Also, this is not like very Testcontainers related, but you can increase the integration between the two teams using consumer-driven contracts.
Yes,
that's another way of testing things, where basically your client writes the tests and you are running the tests against your application when you are building it.
Yes, and this
Spring also has. Just go ahead.
No, they use that, like, so it's like a reverse responsibility, right? So the team that writes mocks, they also write tests, right? And then the application, the service, the dependency runs those tests and thus verify that the contract works, right? And that they verify that the mock actually is truthful to the actual service.
And also, if you happen to use Spring, it has support for that. It is called Spring Cloud Contract.
Oh, that is cool. Do you use Spring, George?
Yes.
Very
Yeah, my main day job when I'm on contract is mentoring large companies to try them to do more testing. So this is good timing. I was totally unaware of the company, which is bad on me. So thank you.
Oh, the company is very new, so you don't have to blame yourself. The company was created somewhere in summer, I think, announced late June. So, which is non-existent amount of time in this challenging situation we are all in. But the library is very, very good. And there are also, if you work not with Java teams and Java projects, then the others they are a little bit different in the maturity and how much of the Testcontainers Java functionality they implement. Testcontainers Java is currently the sort of the flagship and most polished, mature, functionally rich Testcontainers library. But I know that people use Testcontainers Go very efficiently. For example, Elastic is one company that uses Testcontainers Go, and people use Testcontainers Node and so on. Maybe less Python, but well, it will get there with some interest from the community. Excellent. Thank you very much. Do we have any more questions? No.
I think that's all. Thank you very much, Oleg. This was amazing.
Jonathan, how soon do we have the recording of this available so I can share with some of my teammates? Who
hopefully tonight, or like in the next, like tomorrow.
Thank you. Thank you, Oleg.
Yeah. Thank you very much for coming.
Thank you. Let me stop the recording.